Hello everyone, Siddharth this side, and in this video I will be solving another question on Geek for Geeks, which is word prep. So this is a hard difficulty level problem, and in this video I will be discussing two approaches. The first approach will going to be time efficient, and second approach will going to be space efficient. So the other solution that are on YouTube are not that intuitive, but the solution that I have come with is very intuitive. You can understand it very well. And let's start solving this question. So, so let's first understand what is this problem about. So we have given an array named as nums, and in this array we have given the length of the each word. So this 3 is a word. Suppose SID. So this is our word which has length 3. And this is to take any of the word like RA. So this array is representing, and what we have to do, and this k is representing the minimum number of words in a single line, minimum number of character in a single line. So as in this test case, we can put only 6 characters in a single line: 1 2 3 4 5 6. Now, additionally, what information we have given in this problem is that uh, we have to, after inserting a word in a line, we have to make it clean as well, like adding space and all. So suppose we have to write Sid is a coder. So we have to insert, suppose we have to insert these two words in our line. So for that we have to take this space as well, because only then a line will l- look good look good. So, and we don't have to add space for the first word in the start. And additional information is that we have to minimize the cost. What is the cost? Suppose this is a line and we have added three character in this line. Now, according to the given value of k, the left character is 3. So the cost of this line will going to be 6 minus 3 whole square, which is 9. So after inserting all these words in the best possible manner, we have to minimize this cost, total cost, which will going to be, suppose we have insert sid in our first line, and in the second line we just inserted this is. Then the cost of this line will going to be 6 minus 2 whole square, which is 16. So total cost will going to be 16 plus 9, which is 25. So after inserting all of the given words in a line or in a multiple lines, we have to minimize this cost. So let's see like how we can solve this problem. So one thing that we can do here is that first we will calculate the cost of our current word, then we will move on to the next element, and we will take a variable uh, which will which will like which will carry forward our current length. So suppose we have added three in our first word. So current length will going to be 3 plus 1, because 1 is for space that we will add for making a line look good. So the current length will going to be 4. But for first word, we don't have to add any space. So we will initialize it with -1. So when we will add 3 to our current length, it will adds up to uh, now, after adding this 3 plus 1 minus 1, then we will end up with 3 only. And afterwards, we don't have to uh, we don't have to like we have to add space after the first word. We have to add space, so automatically it will take care in the loop. that current in the next, this current will initialize to -1 in the first loop, and in the nested loop, we will not be initializing it again. So by this, we will be handling that the first word case will only be applied to our first word of our line. So after this, what we will do, we will move on to the next element, which is 2. So we will increase our current length to 3 plus 3, as 2 is our element. So we have to add 1 additionally for the space. So our length will become 3. So current length will going to be 6. And after taking 3, we have to calculate cost also in the first iteration. So cost will going to be 6 minus 3 whole square, which is 9. And for 2, we will be calculating cost as 6 minus 3 whole square is equals to 9. So in this manner, we have to calculate the cost of the current word and up to the word from this word, until and unless our current length will become less than, current length will exceed the value of k. And that's where we have to stop. So we have to do this for each word. Now from this, you are getting intuition that we can store the cost into a matrix. So for that, we will make in matrix, we will initialize 2D array as dp, and we will make a n cross n matrix, which is the length of the array or number of words, total number of words. So 0, 1, 2, 3, then 0, 1, 2, and 3. So for 0 comma 0, this is our first word. So our first word is of length 3. So we have to we have to calculate the cost of inserting 3 into our line, which will going to be 6 minus 3 whole square, and that will equals to 9. Now we have to move on to next word, which is our second word. Can we place it into the line where we have placed our first word? So for that, our current length is 3, which is of our first word. Now current length we will apply to loop, obviously. So our current length is 3. Now after moving on to the first, move on to the next word, its length is 2, because our array is 3, 2, 2, and 5. So we have taken 3. Now taking 3 in our current line, we will move on to next element, because we want to take this element as well. So our current length will become 2 plus 1 is equals to 3, and before, this is for 2, because this will occupy 3 space, 2 of its length and 1 of its space. Now the total current length after taking in account 3, current length will become 6. So current length will become 6. Now cost of this will going to be 0. Now after moving on to the next word, our current length will exceed the value of k. So we will initialize it with integer dot max value, suppose infinite here. Now we will take so we don't have to go backwards because we will not put words in backward. So we will not fill this 1 0, which is like taking 1 then taking 0 word, which we don't want. We have to move forwards. We have to move forward into our array. So we will start filling our matrix from 1 itself. So our second word is 2. So second word is 2. So we will initialize our current length with -1, and so 2 plus 1 minus 1 will going to be 2. So our current length is 2, and cost of it will going to be 6 minus 2 whole square, which is 16. So we will fill 16 here. Now our current length will become, after moving on to the next word, the current length is going to be 3 plus 2, which is 5. 3 for this word, 3 for is the next word, and 2 for the previous word. So total this is 5, and 6 minus 5 whole square is 1. So the cost of this will going to be 1 here. Now this is infinite as it will exceed. Now 2 and 2, we will start from 2 and 2 because we don't have to move backwards. So 2 and 2 will going to be 2 only. So 6 minus 2 whole square will going to be 16. So we have to fill 16 here also. Now 2 plus 6, which will for the next word, which is 6 in our array, 3, 2, 2, 5. So 5 is our next element. So our current length will equals to 2 plus 5 plus 1. 5 plus 1 for this word and 2 for the previous word, which is 2. So this will exceed our k value. So we will initialize it with infinite. And now lastly, we will be having the last word and we will be filling as which is 5. 5 is our last word. So we will be calculating its current length. So current length will be going to be 5 only because there will be no space for the first word. So the cost now after calculating current length, we have to calculate the cost also. So 6 minus 5 whole square is 1. But we have given we had given we have given another condition here is that we don't have to count the extra space for the last one. So we will make a condition in our for loops if we encounter j is equals to n minus 1. In that case we will be storing the cost value as 0. So we will be storing 0 here. So this is our final matrix, guys. This is our final cost matrix, but still we have to calculate the minimum cost. So what we can do additionally for calculating a minimum cost, we will be making another array which is cost here of the same length as of our nums. Now we will start from the last word, which is 5. So 3, 2, 2 and 5. So we will start from this word, which is 5. We will start from 5 and we will calculate, we will see what is the cost of putting this word into a line, which is 0 here. Now we will store this 0 here. Now can we store any more words? So there is no words in our nums array. So can we store it? No, we can't, as there is no word. So we will move on to the previous element or previous word. If there is any element further, we will move. We will do some calculation there also. We will see while we will do for the third word. So we will do I minus minus. So now we will be having this word which has length 2. Now for this word, we will first we will first we will try to calculate the minimum cost. So for calculating minimum cost, what we will do, we will find the minimum of our current cost value. We will initialize it with the last value of our, we will initialize it with the last value, which is infinite. Why we are doing this? Because this array is representing the cost of the cost if we put all the words in a single line. You will soon understand. So for suppose we have initialized this dp with our last element. Now for current element, which is this, we have already stored infinite here. Now we will do some calculations for finding the minimum cost. So for that, what we will do, we will make a condition here, maths dot min of our current dp value, which is dp of I, where we have stored infinite already, and cost of ij, which is cost of storing this word in a single line, which is 16 here. So 16 plus cost of the previous word in this array, because this array will tell us the minimum cost. uh, this array will tell us the total cost, but this array will tell us the minimum cost. That's why we have to see here. So here 0 is stored, so we will add 16 plus 0. Now we have to take minimum of these two. Here it is infinite, here it is 16. So in our first iteration we will be storing, second iteration we will be storing dpi as a 16. So here we will store 16. Now I will continue from here after we have coded it out, so you can understand that very well. From this, you have like you guys have can have clear idea what we will going to do in this question. So let's start coding this out, and after I will code, I will continue from there where I had left. So then you can connect these two and you can understand this problem very well. So let's start. So first we will be making our 2D array where we will store our cost. So int uh, this will we will name it as cost, and let's first take out the length of our array, nums array. So int n is equals to nums dot length. After doing this, we will be initializing this cost 2D matrix. So new int n cross n. Now we have to make up. Sorry, this will be okay. Now we will be making our array which will store a minimum cost. So new int. This will also have length n. Now what we have to do? We have to fill our cost matrix. So for that we have to initialize two loops. Int I is equals to 0, I less than n, I plus plus. Now what we have to do? We will make another for loop. So int j is equals to, it will start from I itself. J should be uh, j should be less than n and j plus plus. Now guys, what we have to do? We have to calculate a current length. So for that we have to initialize it as well from outside the loop. So current length is equals to -1. Why we are initializing it with -1? Because I have already had told that for the first word we don't have to take any space, so automatically it will subtract -1 from it as we will calculate current length. So current length. So what we have to add in a current length? We have to add our current value at nums, which is nums j plus 1. So that's why we have initialized -1, because we are adding plus 1 here. If we will initialize it with 0, then it will be calculating space for the first character as well, first word as well, which we don't want. Now what we have to do after calculating our current length, we have to check. After that, we have to calculate cost. So if our current length is less than or equals to k, only then we have to calculate cost. If that's the case, now another condition is that, which I already had told. For this, if j become equals to n minus 1, then we have we have a condition here that we have to store 0 there. So our if j is equals to n minus 1, in this case what we have to do, we have to store cost I j to 0. Otherwise what we have to do, otherwise our cost will going to be k minus nums of j, which I already had told you why the value of the formula of the cost. Now let's multiply it with itself, as we have to calculate a square. So nums of j. Now in the else part, if our current length, if our sorry, if our current length is greater than k, in that case we have to store integer dot max value, which is this infinite we have to store. So cost will equals to cost I comma j will equals to integer dot max value. Okay, so after doing this, we will be having our complete cost matrix. For this test case, we will be having this cost matrix. Now what we have to do, we have to fill our cost, we have to fill our dp array, which will be giving us the total cost, and in a minimized manner. So let's fill dp array from right to left so that we can minimize the cost. Okay, so let's initialize two loops as well. So int I is equals to, we will start from a last word, I should be greater than equals to 0 and I plus plus. Now what we have to do, we have to first in the dpi, in our the last element or the current element, we have to store this value which is last one of that ith value. For 3 we have to store this, for 2 we have to store this. Why we are storing it? uh, because we want to put all the word, like what is the maximum cost for putting all the words in a single line. So after storing this, we will compare it with the next word so that we can take the minimum of these so that we can minimize the cost. So we will initialize the dpi with cost of I and n minus 1. Okay, after doing this, we have to start minimizing our cost. So for int j is equals to, it will start from I itself and j should be less than n minus 1, j plus plus. So after doing this, what we have to do? If we have to check if our cost is not infinite, because in that case already the current length is exceeding, so we don't have to calculate the cost for that. So if our cost I j, if this is equals to, is does not equals to, sorry, it does not equal to integer dot, sorry, let's copy from here, integer dot max value. If that's the case, only then we have to store uh, the minimum cost in a dp array. So dpi will equals to math dot minimum of our current dp value which we already stored here in the start, and the current cost value which is cost of I and j, plus we will be adding dp of j plus 1, which will tell us what is the cost for the word which we already had calculated, which like this will give us the cost of that word which we already had calculated. So as we have to accumulate the cost, so dp of j plus 1, so this will give us the cost of the next word as we are moving backward. So this will going to be our next word. So this will give us the cost of from that word to the next word, which will going to be like in the first iteration. We will talk about this will not get executed as j is 3. So we have applied condition as there is no word after 5, so we will not have to do anything. So after doing this, we will be having like complete solution of this problem, and the dp0 will get us the minimum accumulated cost. So we will be returning dp0. So this is the solution, guys, and there is another solution of this problem as well. So now let's do the dry run as well so that we can understand it uh, very clearly. So where I had left in the start. So in the first iteration, what will going to be happening? So in the first for loop, we will be starting from I is equals to 3. Sorry, I is equals to 3. Let's zoom it out a little bit. So I is equals to 3 and j is equals to 3. So now we will store dp 3 comma 3 to what we will sorry, we will be storing dp3 to what? Cost of 3 comma 3, which I had already told, which is infinite here, sorry, 0 here. So we will be storing 0 here. Now in the inner loop, we have already applied condition j should be less than n minus 1, which is j should be less than 3, but here j is 3, so we don't have to do anything. As you already know, there is no word as well, so we don't have to do anything. So we will move on to next loop. So I will become 2 and j will become 2 as well. Now in the DP array, what we will be storing here in the start, here it is 0. Now here we will be storing I is 2, so cos of 2 comma 3, as n minus 1 is 3. So we will be storing infinite here. 2 comma 3 is infinite. So we will be storing infinite here. After storing infinite here, what we have to do, we will move on to a nested loop. And after moving on to nested loop, what I had told, if we don't have like infinite at 2 comma 2, at 2 comma 2 we don't have infinite, so we will, here you can see, if we don't have I comma j as infinite, then we will be calculating our cost. So dp of 2 will equals to minimum of dp2, minimum of the current, which is dp of I, current value of I, which is infinite, as we have already stored infinite here, and cost of I comma j, which is 2 comma 2. What is the cost of 2 comma 2? It is 16. So cost of 2 comma 2 is 16, plus we have to add the cost of the previous the next word, so that is 0. So we will be this, and we have to take minimum of that, and that is 16. So we will be storing 16 here, so our dp array will become 0 here and 16 here. Now we will move on to I is 2 and j, I is 2 and j will equals to 3 for the nested loop. But in the nested loop, we have applied condition that j should be less than 3. So we will move on. Here it is, the loop will break and we will move on to I equals to 1 and j equals to 1. Now in the start, we have to store something in our dp array, which will going to be dp of 1 should be, what we will be storing, cos of 1 comma 3, which is again infinite, sorry, which is again infinite. So in the in the array we will be storing, here it is 0, here it is 16, and here it will be infinite. Now we will move on to the nested loop, as j is less than 3. So in the nested loop, what we will be doing, we will be updating a dpi again for calculating the minimum cost. So dp of 1 will become equals to minimum of current value of dpi, which is infinite, and previously calculated minimum cost, which is 16 plus current 16 and the current value of cost. The current value of cost is for 1 comma 1 is 16 also. So this will going to be 32. So we will be storing 32 here. Now our dp array will become 32, 16 and 0. Now in the nested loop, j will get incremented, so I is 1 already and j will become 2. So again we will be calculating a dpi, which is dp1 minimum of current value of I, which is 32 comma uh, calculate cost at 1 comma 2. What is the cost at 1 comma 2? Let's see. 1 comma 2, the cost is 1. So at 1 comma 2 cost is 1. So 1 plus the cost, the cost as 1 comma 1 is here, and j plus 1. What is the cost? What is the cost at j plus 1, which is 3? 0, 1, 2, 3. It is 0. So this. So the minimum of these is 1. So we will be updating this to 1 here. Now j will become 3 in the nested loop again after getting incremented by 1. J is equal to 3. So we will break out, as we have already applied the condition. Now I will become 0 and j will become 0. So first we have to update our DP, store something at DPI, and our previously calculated DP array is here. It is 0, here it is 16, and here it is 1 again. Now at I 0 comma 0 we have to store the value which is 0 comma 3, sorry, 0 3, cos of 0 3, which is I think infinite again, something it is there. Okay, it is infinite again. So we will store infinite here also. So after storing infinite here, we have to calculate the minimum cost. So we will move on to the nested loop. So we will update, as 0 comma 0 is not infinite, it is 9. So we will be storing something here. So dp 0 we will be taking as minimum of current value of dp, which is infinite, and cost of the current element, which is 9, plus previously calculated minimum cost, which is 1. So we will be taking 10, and we will be storing here 10. So our final array will become, and if you will calculate for j is equals to 1 and j is equals to 2, you will be getting 10 as a minimum. So 10 160, 10 116 0. This is the answer. This is the minimum possible accumulated cost for this given test case. So this is how this solution will get work, and we will be getting our final answer. So let's try to like run this code. If there is something compilation error, okay, there is error something. Okay, so there should be a semicolon here, and let's see if there is any other problem here. So okay, so another mistake is there, like we have to minus it with current length. We have minus it with nums j. So current length. So after doing this, I think everything is looking fine, and we have to store it with cost I in j. Okay, now let's try to run this. This should be I minus minus. Okay, now let's try to submit this problem. So all the test cases have been processed. Now let's move on to the next approach. And in that approach, we will not make this matrix. We will be like making two array and updating our cost dynamically. So let's move on to that approach. So guys, the videos already become too long. So in the next video, I will be discussing the optimized approach, where we don't have to make the space complexity to big of n square. In that approach, uh, we will be using only omega of big O of n space. So thank you. See you in the next video. Bye.